Alright, so I am going to go through the product and quotient rule that we didn't get to go through in class with you. So we finished up most of the derivative rules, and the one we have left was the product rule. Now, I just want to remind you that when we do sum and difference of functions, and what confuses people is why I'm calling it functions, is each of these pieces right here would be considered a function, and so I can add or subtract functions, and then to do the derivative I can physically just take the derivative of each function and add and subtract them. So we're going to go through the product rule, and the product rule is kind of interesting. What you need to understand is, now that we're learning a product rule, it means that taking the derivative of the product of two functions is not as easy as it may seem. So to find the derivative of two functions that are multiplied, we would leave the first function, but then we multiply it by the derivative of the second function, plus leave the second function multiplied by the derivative of the first function. Alright, and a quick way to write that, another way would be product rule is equal to u v prime plus v u prime. So that's just another way to write it. So what I essentially make you guys do is identify what your u is, identify your v. So over here off to the side, we're going to do, actually I'll do it underneath, u is equal to x squared plus 3. See, u prime, so we're going to do a power rule, bring the 2 down, decrease the power by 1, so that'd be 2x, and remember the derivative of a constant is 0, and then v would be 2x cubed plus 5x, and v prime is equal to, multiply 3 times 2 gives you a 6 as a coefficient, x to the second power plus 5x derivative is 5, because x is to the 1 power. When we decrease, it gives you 0 x's. Alright, and if you do it this way, what's really nice is you can physically just kind of draw this and put a plus sign, and that gives you your product rule. So what do I mean by that? The derivative of the function, so we'll just call it f prime, I guess. F prime will be u times v prime, which is 6x plus 5. And so what I did there, I literally took this branch, okay, and then you're going to put a plus sign in between them, and then I'm going to take the other branch right here, and that would be v, which is 2x cubed plus 5x multiplied by 2x. And multiplying it out will really depend. If I ask you to simplify completely, then you'll actually have to multiply that out. If I ask you to just do your product rule and just simply find the derivative, that would be enough. Alright, next piece is a quotient rule. So, quotient rule, this one is a pain in the butt. The quotient rule, it takes some time. So, I'm going to say it interesting enough. There's a little typo right there. It should say u divided by v. I'm sorry, guys. So, the quotient rule. I am going to write it out in words first, and so when you have u over v, I'm going to call the u the high function and the v the low function. So you'll see me do my quotient rule a little bit differently. So you're going to take the low function, multiply by the derivative of the high function, minus the high function, multiply by the derivative of the low function, all over the low function squared. So the way that I say it, low d high minus high d low, all over low squared. One more time, low d high minus high d low, all over low squared. So you'll hear me say that a lot. It seems to kind of roll off your tongue a little bit better than the actual rule, which would be low function multiplied by the derivative of the high function, minus the high function multiplied by the derivative of the low function, all over the low function squared. So that's one way to write it. Then the other way to write it would be v u prime minus u v prime all over v squared. And all of those would be correct. So you'll hear me say it in class, low d high minus high d low all over low squared. So same thing here. This would be my high function. And that's 2x cubed plus 5x. My high prime will be, so bring that down, so we get 6x squared plus 5, kind of like before. And then over here to the right, and maybe I'll use purple, we'll do the low function, and the low function is x squared plus 3. I don't know why sometimes the pluses don't come through. Low prime, or d low is the other way to say it, would be 2x. So my derivative would be low d of high. So notice what I did first. Low d of high. So that would be low function times d high and then here's the part that most people do get incorrect. Between is a big old minus, and then the minus you're going to multiply by, let's see, high d of low. So high was 2x cubed plus 5x. I have no idea why this pen doesn't want to work. Multiplied by low's derivative, which is 2x. And then the whole entire thing is divided by the low squared. That's this right here. And that's x squared plus 3, whole thing squared. Things to remember, you're going to simplify the numerator, but you're actually not going to simplify the denominator. So, pain in the butt, but we're going to FOIL. So, distribute the terms is what I call it. I know most of you want to always call it FOIL. So, 6x to the 4th plus 5x squared plus 18x squared plus 15. You see that minus sign? That's why I'm going to have this bracket. So you get 4x to the 4th, that's this guy, plus 10x squared. So I want to make sure you remember to distribute that negative. The denominator, you're going to leave it alone. Okay, we don't multiply out our denominators because in the end I actually want a factored answer. So x to the 4th, you have 6x to the 4th minus 4x to the 4th. That gives us 2x to the 4th. 5x squared minus 10x squared is negative 5x squared. 18x squared plus, ooh, didn't notice that guy. So plus 18x squared, and that actually gives me, let's see, 18 minus 5 would give me positive 13x squared, and then plus 15 all over x squared plus 3 squared. And then I believe it's factorable one more time. So the numerator, let's see, what way do I want to factor? I'll do by grouping. So that gives me 30 x to the 4th. Let's see. So the two factors of 30, well, maybe it's not factorable. I thought it was. Oh, it is. 3 times 10. All right. So what do we get? We get that the numerator would be 2x to the 4th plus 3x squared plus 10x squared plus 15. The numerator again, then I'm going to have to factor out an x squared. I get left with 2x squared plus 3. This would be 2x squared plus 3. Divide out the 5, and it is positive, so my factors are x squared plus 5, which is not factorable again, and then 2x squared plus 3, which is not factorable again. And so my final answer for this guy, for the derivative, x squared plus 5, let's see, 2x squared plus 3, sorry guys, all over x squared plus 3 squared, and then nothing else will factor, nothing else will simplify, so that would be my final answer for the product rule. So same rule applies. If I ask you to simplify completely, that would be the final answer. Hopefully I didn't make any little mistakes. And then if I ask you to just simply find the derivative, and I don't ask you to simplify completely, right here, that first step that I did, and I'll highlight it with the highlighter, this step right here, that would actually be a correct answer if all I ask you to do is find the derivative. Alright, so what I did for you here, and this is simply if you want to see a more complicated problem. If you feel like you are comfortable with the product and quotient rule, you can stop the video now, but I am going to do a more difficult problem. So in looking at the problem that we have here, I want you to notice that it has a product and it has a quotient. What I need you to understand is the quotient is the rule that we're going to start with. The fact that that quotient bar is there. So this would be my high, this would be my low. So my high is equal to 2x plus 1, oopsie, times 3x minus 5. My high prime would be, so notice what's happening. I'm taking my high and doing the derivative, and that's where the product rule comes into play. So if I want to do the product rule, then you're using your u's and v's. So you can do u is equal to 2x plus 1, and normally, I'll be very honest, I don't show all this work, but I'm just showing it to you so that you see all the steps. U prime would be 2, v prime would be 3. Remember, the derivative of a constant is 0. So h prime actually becomes, remember how we did it? We multiply u times v prime, so 3 times 2x plus 1, and then we multiply with a plus v times u prime, so u prime is 2, and it does help to simplify in the beginning. This becomes 6x plus 3 plus 6x minus 10. So my h prime is 12x minus 7. Alright, so that's part of my answer. Whew. My low is going to be a little easier, 4x squared plus 6x. My low prime will be 8x plus 6. So now I have everything I need. Therefore, to find f prime, low, d of high, that's this guy. So low d of high minus high, that's this here, d of low, that's a big minus, high is 2x plus 1 times 3x minus 5 times low prime is 8x plus 6, and then all over low, that's this one, squared. And again, so if I asked you to simplify this completely, that would be a big pain. Normally I tend not to do any where you have to multiply out 3 binomials, but I will sometimes have you just check for it to be completely factored. So I would check to see if any of the two terms being, term number 1 is this guy, and term number 2 being this guy, to see if they have any common factors. And they don't, so I wouldn't be able to factor anything. If I was being mean and I asked you to simplify completely, then yes, you would be distributing your terms many, many times. Alright guys, so that should be enough of product and quotient rule. The one thing I want to make sure you understand is some rules that we haven't learned, meaning if I gave you this function, you actually can't do the derivative of it like that. You still have to simplify. And then from here, you could do a product rule, or you can multiply out your terms. So that's one thing you couldn't do. You'll notice we haven't done any sine, cosine, tangents, or logarithmic functions. You'll learn all of those later. Some other things that can be a little bit confusing is once you start learning the product rule, I give you something like this, and you start thinking, oh, it's a product between 2 and x. Please don't use your product rule unless you have to. So this, we know a rule for this. This is a linear function. The derivative is 2. You also can see it also as 2x to the 1 power multiply by 2, x to the 0, which is the same as 2. So we know other rules so that we don't have to use the product rule. Quotients, I would not do a quotient rule for this. Why? Because that is the same as 4x to the negative 1, and then I can do a power rule for that. So you want to avoid the quotient and product rule if you can. Something like this, I would use product rule for. I wouldn't spend the time to multiply out the terms personally. Okay? Quotient rule is tricky, so please make sure for quotient rule that you're forced to use it. So 2 things to look at. This term, let's see, 4x cubed minus 2x plus 5 all over 6x. So that one, I actually don't need a quotient rule for, but flip it the other way, and all of a sudden now I need a quotient rule. So why don't you need it for the first one? It's because it can be simplified. So that can be simplified too. Common denominator of each of these means I can do 4x cubed over 6x, I can do negative 2x over 6x, and I can do positive 5 over 6x. They simplify to 2/3 x squared. Oopsie, sorry guys. X squared, that says 2/3, I know it doesn't look like it, minus 1/3 plus 5/6 x to the negative 1. So now I turn that into a power rule. Problem is, this guy doesn't simplify at all. Okay? That's it. There you go.